Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're back for the final episode of this amp build, and like I was talking about last time, we've got a couple of kind of appearance items to put on. We want to put the indicator light on the front of it, put the little meter on it to measure the cathode current, and then we're going to play around with the amount of shade feedback to try to get the bass response up a little bit and tamp down the high-end brightness, brittleness. I don't know how y'all describe it, but it's just a little top-end heavy. So we're going to work on that and finish this thing up. So let's get busy. Okay, so we're back to do some of the final appearance little things that I want to do to this amp. And while it does look really awesome, I think we can tweak a few things to really dress it up a little more. I ended up going with this style knob, which I think looks really cool. It's got the little numbers around the edge with a little hex on it, and let me see if I can tilt it up where you can get a little better view of it. I mean, I think that really fits the theme of this amp well. And to that end, I was originally going to put a meter on the cathode of the output tubes as I was planning on doing a fixed bias on the grid, but ended up going with cathode bias. So when I was finishing up this amp, there's this blank space here that really needed something. And so I'm going to go ahead and put this really cool meter I found right here. And then we're going to put a fat style toggle switch right here, because back then they wouldn't have had the little micro ones like we have on modern gear. So I went with this kind of fat handle toggle switch. I've got one on the way that's a center off. This one's not. So when it comes in, we'll be using it. And that'll allow us to switch back and forth between the two tubes, or put it in the center to take the meter out of the circuit. And we'll be using a small value resistor in series with the regular cathode resistor to act as a shunt for this meter. And I'll go into all that once the switch gets here. We start wiring that up. For today, we're just going to get this stuff mounted. So we're going to finish up the metal work. So then the last thing we're going to do is install one of these kind of old school pilot lights that has this cool little jeweled amber lens. And we're going to mount it right here in the front in the same position this is for the top and the side to kind of symmetrically balance out the front. So I'm going to go ahead and get these holes all drilled in the chassis. And then I want to get this wired up to the front panel and get this bulb finished. And like I said, get this machine work done, get the meter mounted down. We're going to be using this large size chassis punch to punch that hole in the top for the meter, and I'm going to top mount it. I just think it'll look a little more kind of industrial than it would mounting it underneath, because we are kind of going for a more, I don't know, not really steampunk, but kind of industrial look with this amp. So I think top mounting it will look better, plus it's a lot easier to mount that way. So let me get this big hole punched, get this drilled, and then we'll start working on getting this indicator lit up. The last thing we need to do in the circuit itself is to experiment with the plate-to-plate or shade feedback that I'm going to try on this amp to help boost the low end a little bit and see if we can clean up some of the distortion. So let me get busy on that, and we'll be back in a few once we get these little items buttoned up. Okay, here we go. Got the last of our chassis fab work done, and we've got the little jeweled indicator light here in the front, and we've got this cool knob. We're going to have put our Skunky Designs logo here in the center once we get the final everything done. I usually kind of wait to put that on there till I'm all done. It's kind of the last little finishing touch to kind of signify to myself, we're done. So got the milliamp meter, it's actually a millivolt meter, but it'd be measuring the milliamps on the output tubes. We got this mounted right here, and I think this looks really nice. I did kind of hold it up underneath to see what it looked like. And like I said, this top panel is so thick it looked kind of goofy. So I think it being surface mounted like this, and then I've got a center off switch coming for here, but I went ahead and just kind of stuck this one here to see what it would look like. And I think this kind of standard size toggle switch is going to look really nice right here. And again, like I said, the final one's going to have a center off position and for like off, and then it'll have left and right for the tubes. And yeah, we're done with the fab work. Okay, first we're going to do a pull on one channel, and this is with no shade feedback between the plates of the two tubes. And the two things we want to look at here is what the distortion is at 1 watt, which is 2.2%. The other thing we want to see is what the power output and distortion is at 2 volts RMS. So we're getting 1.38 watts at 3.5%. So first test, we're going to do a very light touch of feedback by putting a 1 meg resistor in. And again, we've got limited power on this amp, and I don't want to insert enough feedback that would hurt the power or require it to be driven harder, because then I'm going to be dealing with having to run a preamp. So here, 1 watt, got a little lower distortion at 2.1, and we lost 1/10 of a watt, but again, less distortion. Now we're starting to already see that we're losing input sensitivity by applying this feedback. And I think we're probably going to end up with diminishing returns pretty quickly. I'm going to go ahead and cut this value in half and drop a 500K one in and look at what that does to our input sensitivity and the distortion. So we've got a fairly big power output loss there without a whole lot of change in the distortion level. We're down to 1.15 watts at 2 volts RMS from, I think it was 1.38 watts. And when we're down in this flea amp power range, losing 1/4 of a watt is a big deal. And we really didn't pick up that much lower distortion from what we saw with the 1 meg. And at 1 watt, we're down at 2.185. So honestly, guys, I think I'm just going to pop a 1 meg across the plates and call it a day. I'm hoping that that will tone down the brightness just a breath and maybe pick up the low end some. So I'm going to do a frequency response test with the 1 meg and with no resistor and see what the difference is. And if we see a touch of low frequency raise up, I think that's probably what we're going to go with and just call it a day. And what we may be seeing here is that these Hashimoto output transformers, the ultralinear taps running to the screens of these output tubes, are doing enough distortion correction that adding this shade feedback just really isn't doing a whole lot. Again, I'm hoping that this will boost the low frequency response just a breath, and I think that will even out the tone of what I was hearing when I was listening to this with zero feedback. So first we're going to do a frequency response curve with no resistor. Okay, here's the curve with no resistor, and I'm going to use Microsoft Paint to compare the two. And this is the curve with the 1 meg resistor in place. And so we're going to paste the no resistor on top of this one. And you can see this little area in the low frequency range drop down some with no resistor, and there it is with the resistor. That's no resistor, and that's with the resistor. So you can see this little range right down here picks up some when we're putting this 1 meg resistor in. If you look at it, that's going to be right around 40 to 50 hertz, which is kind of the range that it felt like that it was missing a little bit. One thing I do want to show you, and this is a lot more feedback than we would ever want to put in this amp given the power loss, but I want to show you what putting a 330K resistor in here would do to the frequency response. I'm going to go ahead and put this in paint. So here's the difference between 1 meg and that's 300K. So you can see it definitely is lifting up the bottom end. It's actually flattening out the whole frequency response. But mostly we're going to hear it down on this lower end down here. So I'm probably going to put a couple of 1 meg resistors in it and go listen to it. And if it still sounds weak on the bottom end, I might try these 330s and just see what they sound like and see how much power loss we actually get in use with an active load. Let me go ahead and do one pull real quick here with the 330 in and see how much power we're actually losing. So at 1 watt, we're down to 2.26%, but that's also all we're getting at 2 volts RMS in. So we're losing 0.4 watts of input sensitivity. And to get back to 1.4 watts, it would take 2.5 volts RMS, which I'm just not sure that's worth giving up. But I am going to experiment with both of those resistor values, and it's a radical enough difference that it should be pretty audible what they're going to sound like, and see if it makes enough power with that lower value resistor in there and see what they both sound like. They might sound so much better with the 330K in it that I end up running a preamp or something to get the power that I need out of it. We'll just see. Anyway, that's it for the tuning section of this, and I'm going to do those little listening sessions and then wrap up this video. Well, here we go. We've got it all finished up finally. Long time coming, but I think this really turned out cool. As you can see, we got our indicator light up here in the front, and I tried several different kinds of bulbs, and I was hoping to use some of the modern LED type bulbs, but I found that the incandescent bulb at 2.5 volts was perfect. It really matches the color of the glow of the tubes with this amber jewel, and it just looked so much better. So kind of a tip of the hat to the old school indicator light over an LED, which again I think fits the whole theme. Got our milliamp meter installed, got the toggle switch that switches back and forth between the two output tubes, and I ended up using a 1.5 ohm resistor, which I'll show you on the other side, that got this meter reading about in the middle with the milliamps that these tubes are pulling. Let me kind of pull this up and see if you can see that the front of it better. I mean, I just think that really turned nice, and of course, since we're done, we got our Skunky Designs logo on the front of it. And I'm going to rotate the amp around to kind of let you see all the sides of it. And here's our motor run cap with this really nice bracket to mount it to the chassis with these little screen. This is the screen vent for the dropping resistors for the driver tube filaments. This is the back of the amp. This is the common, and then we have 4, 8, and 16 ohm taps for both channels, so it'll work with a wide variety of speakers. And then on this end, this screen here vents the cathode resistors to get the heat out from under the chassis. These are our 10-turn hum pots, and then the RCA input jacks are right there. In case you're new to this build, this is our Type 80 rectifier tube, our Type 47 direct heated pentodes, and these are Type 27 indirectly heated triode driver tubes. And I did get this thing connected to my system, and I listened to it for quite a while after I installed the shade feedback. And amazingly to me, that 1 meg shade feedback resistor really gave it a lot of needed bass response and took out the brittleness of the highs and really made this thing sound like I want it to. So I'm done. This is the final product. I'm now ready to publish the schematic, which you can see right here. And then this is the power supply schematic that I used. And as you can see, I've notated the voltages and all the stuff that I got on my sample to help anyone that's interested in building one of these. And this is just a really cool looking amp. I mean, I don't think anybody can deny that this thing looks awesome. So, real quick, I'm going to hook up the dummy loads and some power and show you what it looks like when it's all turned on. So, I was going to show you real quick, and let me zoom in here on our meter. So, I want to show you how this meter works. And we'll let the amp warm up a second. So basically, you just come in and you flip it in that direction, and it shows you what the left-hand tube is doing. And then you flip it the other way, and it shows you what the other tube is doing. And then back in the center, the meter is taken out of the circuit. It's not something you would leave the meter on for. It's just something you can check every once in a while to make sure that the tubes are still conducting like they're supposed to, and you don't have like a hot channel or a weak channel or the tubes getting worn out. It's just kind of a nice feature to have. Plus, I think it just really looks cool on this amp and fits the whole theme of it. I know I keep talking about the theme, but this amp was built as much for aesthetics as it was for the sound quality that it makes. And so let me turn off some of this room light. There we go. I think you can see there what the glow looks like. These, you can't really see the filaments or this tube, but you can kind of just see an overall glow. And then these two, because they're mesh plates, you can see the filaments glowing through the mesh. And I think you can see here too that this indicator light has the same color temperature glow as the tubes do, and really adds to the ambiance when you're listening to the amp at night. We'll say one thing I'm slightly disappointed in is that when I was reading through the data sheets, they talked about that these tubes had a blue glow to them, and that's normal and part of how they operate. And unfortunately, these ones that I have here, these RCAs, really aren't blue glowing much. So maybe that's something they did when they were new, and there was some chemistry that's changed in them over the 90 plus years that they've been sitting around. But hey, that's what we've got. So now I'm going to disconnect this stuff, take the tubes out, flip the amp over, and show you the final wiring that I did to get this meter connected, to get the indicator light hooked up, and how I did the shade feedback resistor. So let me get that done. I'll be right back. So we're going to start out here showing you the shunt resistor that I installed on the cathode of the output tubes to feed the milliamp current that the meter's looking to see to measure the current on the tubes. So originally there was a jumper wire that went from here over to this cathode resistor, and we removed this jumper wire. We put a 1.5 ohm 2-watt resistor in series with this cathode resistor. Then we have these 2 wires that go across this 1.5 ohm resistor, and then they run across here and over to one side of the DP/DT meter switch. And then it's a little harder to see, but there's another 1.5 ohm resistor right here with, again, a pair of wires going across it, and it runs up to the other side of the switch. And we're using Ohm's law to measure the voltage drop across this 1.5 ohm resistor to determine how much current's running through the output tube, which is a great way of utilizing a millivoltmeter to measure the current on tubes inside of a tube amplifier. So let me spin the amp around and show you the other side. And then here we have the 2 pairs of wires coming from the output tube shunt resistor to each side of this DP/DT switch, and then the center terminals, positive and negative, run over to the meter itself so that it gets the voltage drop across that resistor as a measurement of the current through the tube. And then finally we have this indicator light, and we ran a pair of twisted wires up and across this top edge of the amp and down to 1 input tube's heater voltage, so we get 2.5 volts up to our indicator light. It's a 6.3 volt bulb, but running 2.5 volts through it gives it a nice glow without being overly bright. So that wraps up the final wiring of these last couple little aesthetic things. Oh, and I didn't show you this either. Let me scoot the amp over, and I think you can see right here, this is where we put our shade feedback resistor. We ran it from the plate of this tube down and to this side of the coupling capacitor. And then we did the same thing over on this other channel. We ran from this side of the coupling capacitor up into the plate of this driver tube. And I think that was a really neat way to get those resistors installed in the amp. So anyway, I'm going to wrap up this segment and do a final wrap up of this project. Well, here we are. We're finally finished with this amp. I know this took a long time and don't need to go over the reasons for all that, but we're done. And this really was a difficult project for me. And again, I think some of my frustration was because these old tubes had, I'm going to assume, sketchy quality control, or maybe back then the circuits weren't as sensitive, or they were designed to take in the variations in the tubes, but especially the 27 tubes seemed to be just kind of all over the place. And I had some really bizarre problems come up with, just one channel not working at all. Turned out to be the tube. Even though it was flowing current, it didn't respond to grid input or something. I don't know what was going on. Put another tube in it, it started working. Then one of the channels had a weird little crackling in it that just wouldn't go away. Again, bad 27 tube. Let's put another one in it. Then had a problem with the volume control, was real crunchy sounding, like it had dirt in it. You know how they do that kind of sound? And it's like, what the heck, this is a brand new Audio Note volume pot that's supposed to be really high quality. How is it doing this? Another bad tube. So anyway, once I got through all of those problems and then got everything working like it's supposed to, tuning it was fairly easy. The 1 mega ohm resistor sounds fantastic, and very, very minimal impact on the power output, but gave a really nice sonic improvement to the bass response, and more than what I saw on the Analog Discovery 2 is what I heard. It was a big change, and it also tamped down some of the high-end brightness. And I'm not sure if those sorts of things are different when you have a dummy load and when you have an active load and how they respond. So I don't know, but I mean, again, you can't totally go by what you see on meters and measuring equipment. At the end of the day, you have to listen to it and then make changes based on what it sounds like with your system. And if you've got speakers that are different than mine, you may end up tuning this amp differently if you decide to build one. Now, while this was a fun project, and I think this is a beautiful amp, these globe tubes just really look cool to me. I'm not sure that this is a project that I would build purely for listening enjoyment. It was a lot of work. This was an expensive build. I mean, like going with this motor run cap. Does that really sonically make any difference? Especially on an SE amp, I doubt it. But it really looks cool. And again, these globe tubes, they were at the very early stages of tube production. And so I would tend to think that more modern tubes like a 2A3 would be a better project and a better use of this sort of quality of chassis and output transformers and all that stuff. But again, this thing sounds really good. I mean, it's got a unique sound to it of my amps. And while it doesn't sound better than my 300B amp, it does sound better than my 6SQ7 EL34 amp. But I would hope so, considering it's got cheap little 15-watt ED cores, and these Hashimoto output transformers were about $600. And I'm pretty sure that they're a lot higher quality. So, at the end of the day, what would the 6SQ7 EL34 amp sound with these output transformers? I don't know. That might be a big improvement. You know, just some of this comes down to price point and what you're willing to spend. For me to sell this amp to somebody, which I may end up doing, I need to get about $3,000 for it to be worth selling, considering all the money that I've got in this. And I really don't want to take this apart and repurpose it. I would rather, you know, this thing go to somebody else for somebody to enjoy, and then use that money to go build another one of some other type. So anyway, this has been a really fun project, and the whole nostalgia of the thing, I think it's really cool. I mean, I know there's some mixture of periods of stuff like these. Obviously, these are modern output transformers. And then, like, while this meter looks vintage, it was from the early 1950s. And Dolly said she likes it too, so hey, that means a lot. So anyway, I hope you've enjoyed this build series. I'm really hoping that my next project can zip along a little faster, since it's going to be more mainstream stuff and we're not going to be experimenting with esoteric tubes and that kind of stuff as much on the next build. I also want to get into trying the 6P1 in pentode mode, and so that's another project that I want to jump into kind of in the middle of doing this other build. And as always, I think I've got most of the parts to do the push-pull EL84 amp, but there's always like a handful of resistors I don't have. So we may be jumping back and forth between some projects. But anyway, I'm really glad to get this one finished up. So anyway, if you're enjoying this channel and you're enjoying what I'm producing here, please subscribe. I'm really excited. I'm up to 4K subs now, and people are still watching my old videos and stuff, so I hope you're enjoying some of this old content while I'm getting some of these other projects together and getting my life back together, which seems to be coming along pretty well. My health seems to be back together, so we should be able to start zipping along again on some projects. So again, if you're enjoying the content, please subscribe, please like the video, and that's a wrap for the Globe Tube amp. Have a great day!